Good evening, students. Are you able to hear me?
Yes.
Okay. So, the last class we discussed fluid statics, right? In fluid statics, what did we see? Did you guys revise the topics?
Yes.
So, what was the topic we saw in the last class?
So the last topic you taught was Pascal's law, sir.
Yeah, what does it state? So, we did few problems also, right?
Yes, sir.
So, what does Pascal's law speak about?
It says that pressure in a fluid is same at all points when we ignore gravity.
Pressure in a ignore gravity and other condition that should be satisfied. Liquid should be
At rest.
that is okay. It should be incompressible. The fluid which you're using is supposed to be incompressible. You can never forget that word. So, we did a problem on how to calculate the pressure and force that is being transmitted from one place to another with the help of Pascal's law. The next topic that we are going to see is pressure exerted, write down the heading, by a liquid column. Okay. So we are going to see what is the pressure exerted by a liquid column. So what does it actually mean? Suppose I have a container like this. Okay. So in this container, let's say it is filled with a liquid. Okay. So this is called as the surface of liquid. From the surface of liquid, as you keep moving down, okay, observe. If I ask you, what is the pressure experienced by the surface, right? So pressure will be a force in the downward direction, right? So force per unit area, right? So if I ask you, what is the pressure exerted by the surface, it is going to be what? So the pressure exerted by the pressure experienced by the surface will be due to the atmosphere on top of it. So it is going to experience atmospheric pressure, right? If I take a layer, if I break this liquid into layers, actually you cannot see it like this. Liquid is going to be continuous. But if at all we are able to break it into layers, let me call this as first layer, second layer, third layer. Now tell me, on a comparative basis of the first layer and the second layer, will the second layer experience more pressure compared to one or less pressure?
Less pressure, sir.
Why? See, I have a book. Okay. The book is kept on a table. Now, I keep another book on top of it. Okay. Another book on top of it. I call this as first book, second book, third book. And there is another scenario like this. So, in both the cases, on a comparative scale, in both the cases, the book at the bottom, which book at the bottom will experience more amount of force?
3, sir.
So, tell me, case 1 or case 2?
Case 2, sir.
In case 2, it is going to happen. Why? Because
Have
3
more
is
mass on top of it.
It is, yes, it is bearing more amount of weight on top of it. So you have to visualize it like this only. If you look at layer 3, the layer 3 is having 2 layers above it. Layer 2 is having 1 layer above it. So similarly, if you talk about layer 4 has how many layers above it? It has 3 layers. So as you keep moving down, the pressure on the liquid column, as you keep moving down, will keep increasing. That is why we call it as pressure exerted by a liquid column. Are you guys able to understand this? So, if I take a small portion of liquid, okay, if I take a small portion of liquid like this, why I'm using dotted lines is because whenever I use dotted lines, it is imaginary. So when I take a liquid column, okay, then observe what are all the things that are going to happen to it. So to this liquid column, from the top, there will be a force. From the bottom, there will be another force, right? Are you guys able to understand? So if I take this portion of the liquid, if I take this as surface X and this as surface Y, surface X will experience the force on it from above. Surface Y will experience a force from below. Because I'm talking about the liquid column which is in contact with Y. Okay. Now, since this is a part of the liquid, this liquid column will have a weight associated with it, which is called as mg. Guys, am I clear till this point?
So could you repeat it?
So I'm saying the top layer X will experience a force due to the liquid from the top. The bottom layer Y will experience a force from the bottom. Let's call it as F2. Okay. And the cylindrical portion that I've taken is an imaginary part of the liquid. I've taken some part of the liquid. I'm trying to analyze what is happening to that part of the liquid.
And then this imaginary part has its own mass, sir. Wait.
Because you're taking some amount of liquid, no?
Okay, sir.
See, this imaginary part will contain some amount of liquid. No, there is no solid present. But that liquid portion, whichever you have taken in that imaginary part, that portion will have some mass associated. And that mass multiplied with G will give you the weight of that liquid column. Am I right?
Okay, sir.
So,
yes, sir.
So if I say the height of the liquid column which I have considered is H. Okay. So since, wait, I'll use another color. Since the liquid is in equilibrium, okay, can I say F1 plus mg is balanced by F2? What I did is sum of all the downward forces is equal to sum of all the upward forces. So there are two downward forces acting. One is F1 and the second is mg. F2 is an upward force, right? So in this chapter, what we will do is we will write force as pressure into area. You will write mass as density into volume. Guys, am I clear? So this is a regular pattern that we will be using throughout this chapter. So wherever you see force, you cannot write it as M into A because we are not defining the mass of a particular system. You're not defining the mass of a particle. You don't know what its center of mass, right? So here what we are going to say is force will be equal to pressure into area. Similarly, mass is always density into volume. So how can I write F1? F1 is pressure at point 1 into A, where A is the area of cross section of this portion. Plus, what is M? Rho into V into G is equal to, you guys tell me what should F2 be?
P2A, sir, or P1?
Yes. No, it is P2A because pressure at point 2 is different. No? Pressure at point 1 is not the same as pressure at point 2. See here, one confusion that will arise is, in the case of Pascal's law, we are ignoring the effect of gravity. Effect of gravity is ignored means what is ignored according. So look at this mathematical equation. If I ignore the effect of gravity, then which out of the three terms, which term should not be used?
Oh, mg will not be used.
mg will not be used. Okay, that is why we are saying that pressure is equally getting transmitted. Whereas when you take the effect of gravity into consideration, that mg is going to be there. Okay, so P1A plus rho into, what is the volume formula? Volume is base area into height into G is equal to P2 into A. Since volume is equal to right. So P2 minus P1 into A is equal to rho into G into H multiplied with A. A and A will get cancelled, which implies P2 is equal to P1 plus rho GH. This is a very, very important formula. This is also called as variation of pressure with depth. So as you keep going deep into the liquid, the pressure on you will start increasing.
So how will the questions arise?
That we will see. You first make a note of this that I'll explain. Done?
Yes.
Now listen. So this is variation of pressure with depth. Okay. So some important points. Write it down. First, liquid pressure is same at all points at same horizontal level. Or I can call it as same depth. So write a note of this. Make a note. First point. Okay. So I'll explain this point. So when I took this cylinder, right, if I talk about any point on the cylinder, okay, any point on the cylinder or outside the cylinder, if that point is at the same depth with respect to the surface, then the pressure at every red point that I've taken is P1 only. That is the meaning of liquid pressure is same at all points. Okay, this is the first point. Second, pressure at any point inside depends on the depth h. Okay. Because pressure at point 2 was P1 plus rho GH. No, it depends on H. third point. Okay. Absolute pressure, absolute means actual, okay. So absolute pressure P at a depth H below the liquid surface, which is open to the atmosphere, is greater than the atmospheric pressure by an amount H or rho GH, by an amount rho GH. Okay. The excess pressure, that is P minus PA, is called gauge pressure. I'll explain the third point also. First, make a note of it.
I have a doubt.
Tell me.
And the third point, the second last line, what have you written, sir?
The excess pressure. The excess pressure P minus PA is called as the, see, we can either pronounce it as gauge or some people call it as gauge, whatever it is. So I call it as gauge pressure. That is the excess pressure.
Okay, sir.
So this is also an important point. So what they're trying to say is, if you take a liquid column like this, which is exposed to the atmosphere, at a depth H below the surface, if I take the pressure at this point to be P, and the pressure here is PA, then P is equal to PA plus rho GH, which implies P minus PA is equal to rho GH. Are you able to understand? So this P is called as absolute pressure, and P minus PA is called as gauge pressure. GAUGE.
So I can explain it again, sir.
What did I explain? Which point?
This point, sir, that U is equal to P.
Did you understand?
Yes, sir, I understood that, sir.
I did the same thing. This is P2, this is P1. So P2 is equal to P1 plus rho GH. P2 is P, P1 is PA. That's what I used it as a formula. Where if you calculate just P, that P is called as the absolute pressure. If you calculate P minus PA, that P minus PA together is called as gauge pressure. That is rho GH. So depending on the question, you have to answer. If they ask you to find the absolute pressure, you need to find PA plus rho GH. PA stands for atmospheric pressure. Atmospheric pressure means it is a pressure exerted by the atmosphere on top of the surface. Okay. The last important point. Pressure does not depend on the cross section or base area of the shape of the vessel. So pressure does not depend on cross section or base area or shape of the bottom of the vessel. The meaning of this is whether I have a rectangular tank or I have a shape like this or I have a shape like this. If I need to calculate the pressure at the bottom, then in all the three cases, if the level of the liquid is same, okay, if it is H. So in all the three cases, what will happen is P1 will be equal to P3. So what is that geometrically we are able to see differently? The shape of the base is different, but what is happening? The pressure is the same because for a liquid column, what does the first point say? Liquid pressure is same at all points, which are at the same horizontal level. So since in all the three cases, the liquid column is having a depth of H, the pressure at the bottom will be the same in all the three cases, irrespective of what? Irrespective of the shape or cross-section area of the base. Guys, am I clear till this point?
Yes, sir. So we can say that the pressure depends only upon the depth of the vessel.
Yes, it depends only on the depth. That's what the second point says. No? Pressure at any point inside depends on the depth H. Okay. So you asked me, right, what kind of problems will come? So there is an NCERT problem like this. I'll take a simple example. What is the pressure on a swimmer 10 meters below water level? You guys solve and tell me.
So what's the question again?
What is the pressure on a swimmer who's 10 meters below the water level? There is only one formula that I thought. Use it.
So G should be taken as 9.8 only, sir, or 10.
Yeah, G, you can take 10 also. I'm not concerned about that 9.8 or 10. Other things it should be right.
Sir, I'm getting 1 point. Sir, I'm getting 2 into 10 to the power 5, sir. 280.
2 into 10 power 5.
Sir.
How did you do?
Sir, the formula, sir. P2 is equal to P1 A plus. P2 is equal to PA plus rho GH, sir.
Okay.
Sir, then pressure, I took it as 1.5, sir.
Okay.
Sir, and P atmospheric pressure is 10 to the power 5, sir.
Okay,
Yes.
got it.
What's up?
Got it. So, I thought you guys will ask me what is the value of atmospheric pressure. So So the value of atmospheric pressure is 1.01 into 10 power 5 Pascal. Okay. Plus rho is how much? What is the density of water? What is the column that you use? Water.
1000.
So density of water is 1000 into G. If I take it as 10, height is 10 meter. Got it?
Yes, sir.
Okay. Next is the next concept that we are going to see is buoyancy.
Sir,
Yeah, tell me.
the atmospheric pressure 1.05, sir.
1.05. It is 1.015 into 10 power 5. That is the general value.
Okay, sir.
Okay. Now listen. The next concept is buoyancy. That is, we are going to see what is Archimedes' principle. Okay. Before that, we need to understand what is buoyancy. You have heard this word, right? You know what is buoyant force, right? So the concept of buoyancy comes into picture when a solid comes in, or I can say like this: solid is immersed in liquid. So, listen. What happens is if you have a liquid column, need not be water. Let's say I'm giving you a small wooden block. Okay. As soon as you keep the wooden block on top, let us say the wooden block is light enough that it is floating. Now, if you start applying a force in this direction, right, the wooden block will get immersed into the liquid. But what do you think is going to happen? You would have experienced this in everyday life.
Water.
Water the level of water will get raised in the first place, right? And secondly, the water also will start applying a force in upward direction. It try to push the object away from it. It doesn't want to have it itself, right? So there is a phenomenon, natural phenomenon that is existing for that particular liquid to send the solid out when you're trying to immerse the solid into the liquid, right? So that particular force which is applied by the liquid is called as buoyant force, and this phenomenon is called as buoyancy. Guys, am I clear? Okay, so write it down. So if I ask you about buoyant force, what will you say? It is an upward force exerted by whom? So upward force acting on an object during what scenario? Immersed in a liquid is called buoyant force, and the phenomenon is called as buoyancy. Now tell me one thing, guys. What is the other name for buoyant force? So buoyant force is acting in which direction?
Upward direction.
Okay. I told you there is another name for force in this chapter. What is it?
Hydrostatic pressure.
No. That is pressure. When I explained pressure yesterday, I told you. What is pressure? Start with T.
Thrust.
Yes. So buoyant force is acting in upward direction, so up. And since the other name for force is thrust, buoyant force is also known as upthrust. Am I clear?
Yes.
Okay. Now comes the next concept. Write a note. Buoyant force always acts through center of gravity of the displaced fluid. So what do you mean by displaced fluid? The fluid which gets raised.
Sir, can I say the definition for the displaced fluid, sir?
Sorry, no?
Can you
You
say
want to know
the
what?
yes, sir,
Yeah.
displaced fluid? I can say it.
See, I told you one thing, right? When you immerse a solid, what will happen? The liquid will start getting raised, right? So I'll repeat it again. Listen. Let us say this is the level of liquid. Okay. Let me call it as H. As soon as I immerse a solid, what will happen is this portion of the solid is in contact with the liquid, right? When you have immersed, this volume of the liquid, whichever is there, will try to occupy on either side of the solid and it will get raised so that the volume is conserved. Means, can I say the new height is H dash? So, and we are clearly able to see that H dash is greater than H, then this H dash minus H is called as the displaced fluid. Am I clear? Mithun, are you clear?
Yes, sir.
Good. Okay. So from this, we are going to develop or we are going to learn a concept called as Archimedes principle. Write it down. So what is Archimedes principle, guys? So what does this state?
Not
Anybody who can?
sure, sir. But I
But you
think
can try.
it means that amount of volume of the liquid displaced is equal to volume of the solid immersed.
That's right. That's right. That's right only. So that's the technical way of defining it. See, that is obvious because volume has to be conserved. Solid is not going to, the liquid is not going to get evaporated. It has to get displaced. There is no other option. So one way of stating it is like this. So I'll give you two statements. One is like how you stated. It states that when will this principle come into existence? When an object, when I say object, it's a solid object. When an object is, can I say, it can be partially immersed or completely immersed. When an object is partially or completely immersed in a liquid, what will happen? Like how you told, volume of liquid displaced should be equal to what?
Volume of solid
Volume of,
immersed.
can I say immersed portion of the solid? So immersed portion of solid. So this is purely happening because of what? The volume conservation technique, right? So let's see the alternate one. The alternate one is what is expected in your 11th standard. This is the one which is told in your 9th. I'm not saying it is because of 9th and 11th concepts are wrong. It is the same concept. In 11th standard, we are going to deal with more technical aspects. That is, we are going to see what are all the mathematical formulae that are related. Because in your 9th standard, you would have learned what is buoyant force, but you never knew what is the formula for buoyant force. How it exactly works, right? So now we are going to see all those things. For that, see, Archimedes principle is stated in terms of buoyant force. How is it stated? So write it again. When an object is partially or completely immersed in a liquid, then what will happen? It experiences an upthrust, which is nothing but buoyant force, right? This upthrust is developed in such a way that upthrust, which is equal to weight of the liquid that is displaced. So which is equal to the weight of the liquid that is displaced. Am I clear, guys? So this principle has so many things to tell. Okay. If you have written down the statement, let me explain what the statement actually means. Listen. So by now, I hope everyone is clear with what is the meaning of displaced liquid, right? So this is the liquid alone. When the solid is partially or completely immersed, there is some amount of volume that is going into the liquid, which I'm calling it as VI, where VI is what? VI is the immersed portion of whom?
Of the solid.
Immersed portion. Yes. So the same volume of the liquid will get raised. Okay, for that I will use a different color. See. So can I say the red color portion put together will be the same volume that has got displaced? So VI portion of the liquid would have got displaced. VI portion of whom? Of liquid would have got displaced. Am I clear, guys? Right. So if I calculate the weight of displaced liquid, okay, that's what they say, which is equal to weight of the liquid displaced. If I ask you what is the weight of the displaced liquid, that will be, see, weight has only one formula. What is it?
mg.
Mass. Okay, here mass of the liquid into G. Can I write it? So I told you in this chapter we don't write mass directly because we cannot calculate mass. Rather we depend on density. So can I write density of liquid into, what should I write? How much volume of the liquid has actually got displaced? Guys, I'm repeating it again. So I need mass of liquid. So mass of liquid means density of liquid into volume of liquid only. But here, what is the volume of the liquid that is getting displaced? Yeah, Rohan, what is that you told?
VA.
It is VI into G. So this term, the product of these three variables, gives us what? Weight of the displaced liquid. But according to Archimedes principle, the weight of the liquid displaced is what is called as the buoyant force. So to put it in simple terms, this is the formula for buoyant force. Guys, I hope it is clear. We'll be using this formula.
Yes, sir.
Yeah.
Sir, can you explain the formula again, sir? Rho and VI, that and all.
Concentrate. Yeah. So weight of the displaced liquid. Okay. So weight of the displaced liquid is mass of the liquid into G, because weight is only 1 form mg. I'm asking, what is the mass of the liquid that is getting displaced? Mass is equal to density into volume. So mass of the liquid displaced is density of the liquid into how much volume is getting displaced. What is the first statement of Archimedes principle state? The volume of the liquid displaced is equal to the volume of the immersed portion of the liquid. Then the volume of the liquid displaced should be Vi, right? And G is already there. This density of liquid into volume of immersed portion of solid into G is what is called buoyant force according to the mathematical way of representing Archimedes principle.
Sir, so VI is the volume of solid, sir.
Yes, volume of immersed portion of solid. See, volume of immersed portion of solid is the same as volume of the displaced portion of the liquid. They both are same. That's what I mentioned here.
So then what is G, sir?
V is volume that we will take. Why are you concerned about it? You concentrate only on this particular part. V is some other variable. You don't concentrate on variables. You should concentrate on the context. In this context, VI means volume of immersed portion. I never introduced the term V
No,
at all.
sir. G, sir. G.
G is acceleration due to gravity. Weight is mg, no. G is acceleration due to gravity, 9.8.
Okay, sir.
Yeah. Okay. Now see. See. The block is there. See, let's say I have a block of mass m. Okay. Listen to me carefully. I have a block of mass m. I want to measure the weight of it by using a spring balance. So, tell me one thing. When I suspend this mass across the spring balance and leave it freely, let's say the extension that is taking place in the spring balance is x. Okay, was I clear? So I'm suspending a block of mass m which is connected to a spring balance, and I'm observing the extension. The extension that has appeared in the spring balance is x. Are you guys clear with this? Now, I take the same system with the spring balance and mass, I immerse it into a liquid. Now, in this scenario, so in this scenario also, let's say there is some extension in the spring. But my question is the extension going to be more, less, or equal to x? Will it be more than x? Will it be less than x? Or will it be exactly equal to x?
Less.
Sorry?
Might be less.
I'm not able to hear you. You're saying it will be?
Might be less.
Might be x.
Less. Less. Less than the before.
That's what I'm asking. Is it going to be less than x or greater than x?
Less than x.
Less
Why?
than X, sir.
Less than
Because
X
of
is
the
right.
buoyant
Okay,
force.
that's right. So here what is happening? Here it is mg that is acting. Whereas here there is mg acting as well as there is a buoyant force acting. So the spring is undergoing two forces. So in the case when the block is suspended in air, mg is equal to kx. Whereas here mg minus fb is k into x dash. So in this case, what will happen is x will definitely be less than. So x dash will be less than x. Okay. So there is a reason why I explained this.
Sir,
Because yeah,
sir, if mg is greater than buoyant force, means won't the solid immerse in water, sir? Like fully sink down.
it will not get fully.
Sir, if
Need not be.
the volume of the solid is greater than the buoyant force.
No, it will not. Because there is a spring which is holding it.
Okay, sir.
Okay. Now listen, guys. So how a spring balance works is, if I have a pointer here, okay. So if the reading here is 0 and here it is 10, as you move down, okay, as you move down, the readings will increase. To put it in other terms, more is the extension in the spring, more will be the readings. What does a spring balance read? Spring balance gives measurement of what? Mass and weight. Okay. So if I have to say a reading of a spring balance is more, then the extension, the spring balance also has to be more. Am I clear with this point? Guys, am
So
I
could you
clear?
repeat?
See, the spring balance is there. Let's say there is a pointer. Okay. Here there is 0. And as you go down, you can see that the readings are increasing. 1, 2, 3. It keeps on going. Let's say till 10. Now let's say I'm suspending a block of mass 5 kilogram. Then I'm replacing and suspending a block with a mass of 7 kilogram. In which case will the extension of the spring balance be more?
7, sir.
7. That is what I meant. So spring balance gives the measurement of mass and weight, right? So more is the extension. So more weight you suspend, more extension will take place in spring, and more will be the mass value of the mass it is measuring. Okay. In that context, tell me, is the spring balance in these two scenarios? Okay, I'll call it as case 1. I wrote case 1 on the right hand side and case 2 on the left hand side. Tell me whether in case 1 or case 2 is the spring balance going to show more reading?
In case 1 only, it will show greater, no, sir.
It show greater reading. So that is, if I have suspended a block of mass 5 kilogram, when it is suspended in air, the spring balance will show a reading of 50 Newton. Am I right? So when a mass of 5 kilogram is taken in air medium, the spring balance will show a weight of how much value? Mg, that is 50 Newton. Whereas when the same block is immersed in water, the spring balance will not show 50 Newton, rather it will show a decreased value. So can I say that there is a decrease in the weight of the solid that is being immersed? Are you guys able to understand why it will not be 50 Newton, why it is going to be less than 50 Newton?
Yes, sir.
Okay. So why is it happening? You guys only told me. In liquid, weight of solid measured is equal to what? It is the actual weight
Minus buoyant
minus,
force.
very good, buoyant force. Right, that's what I've written here. mg is the actual weight minus buoyant force. So what is the actual weight of solid? It is density of solid into volume of solid into g minus, what is the formula for buoyant force I gave you? Density of solid, density of liquid into volume of
Volume.
immersed portion into g, right? So this decreased weight is what is called as apparent weight.
Can you say what is PS, sir?
What is
PS.
Vs is volume of solid. Rho s is density of solid, Vs is volume of solid, g is acceleration due to gravity.
Sir, I have a doubt.
Tell me.
Sir, we float in humans float in water due to buoyant force, no, sir.
Yeah.
And how can people drown, sir?
How can people drown?
Yes, sir.
That is because we are not balancing ourselves. See, when a swimmer is actually able to swim, his center of mass will exert the weight in the downward direction, mg, right? If the buoyant force is also exactly able to act along the same line of action, okay, if it is able to act along the same line of action, the swimmer will be able to balance. But what we do, if a person doesn't know swimming, he goes like this, mg will act here, fb will act here. As a result of which, it is completely a scenario where they are not able to balance themselves. That is why they drown.
Yes, I
Okay.
understand.
So here comes an important point. Good that you asked. So what did I say? I told you an important point about buoyant force. It always acts through the center of gravity of the displaced fluid. Okay, that is a very, very important point. Based on this only, all the ships and all are designed. Then you take all those things into consideration. How the bottom is supposed to be. How do you maintain the stability of a floating object? And all those things. Okay.
Understood, sir.
Yeah. So I hope you're clear with what is apparent weight also. In physics, apparent means the decreased value. So most of the places you will see. Apparent means decreased value. Okay. One small concept I'm going to explain now. Then we can wind up. That's called law of flotation. Okay, write down the statement. It states that an object will float. It states that an object will float in a liquid. An object will float in a liquid if the weight of the liquid displaced, by the immersed part of the object, if the weight of the liquid displaced by the immersed part of the object is equal to or greater than the weight of the object. Okay. So what they are trying to say is, if I have a liquid column like this, okay, in one scenario, I am immersing the solid like this. It is partially immersed. In other scenario, it is completely immersed. Okay. Now try to understand. For the solid, its weight will act downwards. Due to the liquid, the buoyant force will act in the upward direction. I write it as FB. Okay. In this case also, weight is acting in the downward direction. FB is acting in the upward direction. I hope it is clear in both of you. Both the diagrams are clear, right? Now read what the law of flotation states. Rohan, can you read it out? It states that an object will float.
Will float in a liquid if the weight of the liquid displaced by the immersed
So
part of the object.
Wait. Let's pause. What do you mean by weight of the liquid displaced? According to Archimedes' principle, weight of the liquid displaced is equal to something else. What is it?
Volume of the immersed object.
No. Weight and volume cannot be compared. No, weight is a different physical quantity. Volume is something else.
Immersed portion of the object. Solid.
Weight of the liquid displaced is equal to, someone is saying. What is it?
Immersed portion of the solid.
Weight of the liquid displaced is equal to upthrust. I've been telling no. Weight of the liquid displaced is buoyant force. So remember, wherever you see weight of the liquid displaced, indirectly it is buoyant force. So what are they saying? If buoyant force is greater than the weight of the liquid, or buoyant force is equal to the weight of the liquid, in both the scenarios, the object will float. So here, FB will be greater than W. Here, FB will be equal to W. Okay. But there might be a third scenario that is possible. What is it? The solid is completely immersed in the liquid, but it is not able to get balanced. Means you can find the solid only at the bottom. So what do you call this scenario as?
Sinking.
Yes. So the object is at the bottom means, in this scenario, what is happening, guys? W is greater than FP. Means the buoyant force is not sufficient enough to stop the object from moving down. Okay. If you just give me 2 more minutes time, you will understand before you ask any doubt. Just tell me whether you're able to understand this concept.
Yes, sir.
Yes, sir.
Right. So what I'm doing is, for case number 1, what I'm going to do is, when I say FB is greater than W, what is the buoyant force formula? Density of liquid, volume of immersed portion into G. Okay, I will take the second scenario, guys. Okay, let me take this itself. Is greater than density of solid into volume of solid into G. Can I write it like this?
Yes, sir.
So when I cancel it, I get volume of immersed portion divided by volume of solid is greater than rho s divided by rho l. Okay, so when density of solid is greater than density of liquid, what will happen? Okay, I'll take it in reverse. When the density of density of liquid is greater than the density of solid, what will happen? The object will float. You guys know this, right? Similarly, when the density of liquid is less than the density of solid, it will sink. That is why when you drop an iron nail into a liquid, generally it goes to the bottom. You can collect it at the bottom, because the iron nail, though it is smaller in size, it is more dense compared to water. The molecules of water will not have sufficient strength to stop the iron nail from moving down. Okay. So this expression is a very, very important one. What is the significance of it? I will explain it in the next class. Okay. So till then, I want you to revise all these things. See, this chapter is slightly tricky. Unless you guys revise, I cannot help. Do not understand problems, then don't ask. You guys need to practice, okay?
Lesson over, sir.
No, it's a very big lesson. Lesson over. It's a very big lesson. It will take some time. Oh, you thought I put end? No. That's for today's class. Okay, just wait for a minute. Don't leave.